Hi, and welcome to my aquatic science video. Today we will be talking about aquatic science in all of its glory. First, I will start with oceans, then to rivers, lakes, and wetlands, then onto human impact, and I will finish with aquariums. But first, let me give you a little info about aquatic science. Aquatic science is the study of the planet's oceanic and freshwater environments. Aquatic science covers everything from the deep trenches of the ocean to water treatment plants in the rural of a city. Here in Texas, we are very lucky to have all types of aquatic ecosystems in one state. From freshwater to saltwater, we have it all. Although we don't have any oceans directly by Texas, we have gulfs, such as the Gulf of Mexico, that connect to oceans such as the Atlantic. And speaking of oceans, how about we get started on our first topic? Scientists say that the origin of our ocean water dates back to 4 billion years ago. They say that enormous quantities of water surrounded the Earth as a dense atmosphere of water vapor. And at the top of the atmosphere, where there was no heat, the water vapor turned into liquid and fell down onto the Earth's surface. Scientists say that this rainstorm added an inch of water every 10,000 years, which is enough to fill the ocean if this process started 4.5 billion years ago. More than half of the ocean is 10,000 feet deep. Scientists estimate that 230,000 marine life forms of all types are currently known, but the total could be up to 10 times that number. Now that we've gotten some basic info of the ocean, let's get into some details. Ocean zones can be divided into two basic regions, the pelagic zone and the benthic zone. The pelagic zone is anywhere in the water, while the benthic zone is the seafloor. The pelagic zone can be divided horizontally into two zones, the neritic zone and the oceanic zone. The neritic zones is those near the coast, and the oceanic zones are those away from the influence of land. Now, the pelagic zone can also be divided vertically into 5 zones: the epipelagic zone, the mesopelagic zone, the bathypelagic zone, the abyssopelagic zone, and the hadalpelagic zone. The photic zone consists of the pelagic zone. This part is also known as the epipelagic zone, and it covers the ocean from surface level to 200 meters in depth. This is the region where photosynthesis can occur, and therefore is the most biodiverse. Life deeper than this region must rely on another energy source. The benthic aphotic zone corresponds to the 3 deepest zones of the sea. The bathyal zone covers the continental slope down to 4,000 meters. The abyssal zone covers the abyssal plains between 4,000 meters and 6,000 meters. Lastly, the hadal zone corresponds to the hadalpelagic zone, which is found in the ocean trenches. Now that we've covered the zones of the ocean, let's get into the water itself. The ocean consists of salt water. Scientists call the amount of salt in the ocean salinity. Most of the salt in the ocean is sodium chloride or common table salt. Chemical weathering from rocks on the continents is one source of elements found in seawater. The second major source of elements is the Earth's interior. Although the ocean is so big and it seems it would be impossible to increase or decrease salinity, there are many factors that can increase or decrease it. Some processes that decrease salinity are precipitation, melting of sea ice, melting of icebergs, and runoff from land. Some processes that increase salinity is evaporation and the formation of sea ice. The ocean's surface water temperature varies with the amount of solar radiation received, which is primarily a function of latitude. The thermocline is a layer of ocean water between about 300 meters and 1,000 meters, where there is a rapid change of temperature with depth. The thermocline is a very important structure because it creates a barrier to marine life. Sea surface temperature is highest at the equator and low latitudes because these areas receive the most solar radiation at the highest angle of incidence. Now, onto the organisms of the ocean. Marine organisms can be classified according to where they live and how they move. Plankton includes all organisms such as algae and bacteria that drift with the ocean currents. There are 2 types of plankton: phytoplankton and zooplankton. Phytoplankton are algae plankton, which are the most important community of primary producers in the ocean. Zooplankton are animal plankton. Nekton includes all animals capable of moving independently of the ocean currents by swimming or other means of propulsion. Benthos describes organisms living on or in the ocean bottom. The next topic I will be discussing is the Port A field trip. The Port A field trip was probably the next most fun trip just because of the different activities we got to do. So when we got to Port A, the 8th period class went on the boat before us, so we just roamed around on the beach until then. But once we got on it, it was pretty cool. I think for about half an hour the boat just kept going farther out into the bay. But once we got far out enough, we did this activity where the biologists filled up a bucket with mud, and each group got a petri dish full of mud, and we had to separate the things we thought were organisms or were interesting. And there was one thing that was in like a noodle-shaped shell, but once we took it apart, there was an actual organism in the shell. And after that activity, the biologist threw out a big net in the water, and the boat went back towards the dock. But the biologist was actually collecting fish and bottom-dwelling animals, and while they were collecting animals, there were 4 dolphins that started following our boat. So after a while, the biologist brought the net back in, and there were so many fish in the net. I think there was at least like 20 fish there. We also caught 2 little squids and a pufferfish. So once we put all the fish into buckets, each group got a bucket of fish, and we got to examine them with our group. I thought this was really cool because we actually got to see the fish up close and hold them too. The next topic is dissections. During our week of dissections, we dissected about 6 organisms. Those organisms were the starfish, crayfish, squid, oyster, shark, and the perch. I really thought this was cool and interesting because we got to actually see what was inside the organisms we were studying. And a lot of us were surprised. Also, I think at all of high school I've only dissected like 2 or 3 organisms, so this kind of made me more experienced in that, I guess you could say. So starting with the easiest dissection, I would say it was the crayfish, just because there wasn't really a wrong way to do it, whereas if it were fish, if you poke it wrong or something, you could pierce an organ and just spill everywhere. My favorite dissection would probably be the squid, because me personally, I really like calamari and I never knew how it was made or where it was made from. So this dissection really educated me more on the squid and on one of my favorite dishes. I feel like the hardest dissection was probably the perch fish, because I feel like it was so sensitive and like if you poke somewhere wrong you could easily injure it, if that makes sense, I guess. Our next topic is rivers and streams. A stream is a body of water with a current and is smaller than a river. Streams usually get their source of water from a spring, melted snow, or even a lake. As water flows farther down, it may pick up more water or maybe even join together with another stream, creating a river. Rivers are bodies of water with a current, but are larger than streams. A river could even be formed because of a watershed. A watershed is the area of land that channels rainfall and snowmelt to creeks, streams, and a river. There are a few types of watersheds: closed watersheds, open watersheds, and multiple open watersheds. A closed watershed empties into an inland body of water, and open watersheds can empty the water into a river of some sort that empties into an ocean. A multiple open watershed is similar to an open watershed, except instead of one river stream, there could be two rivers emptying into an ocean. There's rivers and streams, and there's also tributaries. A tributary is a stream that flows into a large stream or other bodies of water. There are 3 courses of a river: upper, middle, and lower course. The upper course is where the river usually begins, usually from a mountain. Since most rivers start from a mountain, they have a steep gradient. In the upper course, where a river begins, it's usually where a few streams join up to form a river. The middle course is where more tributaries join the river to make a wider river channel than the upper course. The middle course has a gentler gradient compared to the upper course since it's farther down the mountain. It's also where the river starts to meander. Next is the lower course. This course has a wider river channel than the middle course and a higher volume of water. But over here is also where the river begins to break up into multiple rivers to empty out into the sea. There's courses of a river, but there's also 3 types of rivers. The 3 types are youthful, mature, and old. Youthful rivers are usually more steep and have a quick flow, while mature rivers are less steep and flows slowly compared to the youthful river. But there are many tributaries that feed into a mature river, whereas in a youthful river there are very few. Old rivers have a very low gradient and depend on floodplains. Now on to streams. There are 3 main types of streams. The 3 main types are ephemeral, intermittent, and perennial streams. Ephemeral streams are streams that regularly exist for short periods of time. Intermittent streams flow at different times of the year, or seasonally when there is enough water for rainfall, and perennial streams flow year-round. Some abiotic factors of a stream are precipitation, landscape, and temperature. Precipitation can determine the formation of a river or stream. The amount of precipitation determines which type of river stream forms. Landscape can determine the direction of a river or stream. Temperature affects the organisms living in the stream. Temperature can also affect reproduction occurring in the stream because some organisms can only breed above a certain temperature. There are a few biotic factors in a stream. Air spaces in a stream can decrease density and increase buoyancy. Humans also have a big impact on rivers and streams. Humans drain rivers and streams. They divert and regulate rivers and streams using dams. Dams trap the suspended and dissolved load, starving the area downstream of sediment and nutrients. A barrier to any aquatic life going up or downstream, which can prevent aquatic life from mating and reduce the diversity of wildlife upstream. When houses or businesses are built in a floodplain, they get flooded. That increases runoff into streams, which further increases the chances of flooding. The next ecosystem I will be talking about is lakes and ponds. There are 4 main types of lakes: glacier lakes, oxbow lakes, playas, and man-made lakes. 10,000 years ago, glaciers moved acting as scouring pads. They left behind large deposits of ice in hollows between hills, which later melted to create lakes. Glacier lakes were carved out by glaciers, which fill with water. The Great Lakes are the largest glacial lakes in the world. Oxbow lakes are formed by meandering rivers, which the loops of the river gets cut off. These lakes are long and narrow and usually U-shaped. They are more common in low valleys and flat coastal areas. An oxbow lake forms like this. On the inside of the loop, the river travels more slowly, leading to deposition of silt. Meanwhile, water on the outside of the edges tends to flow faster, which erodes the bank, making the meander even wider. Over time, the loop of the meander widens until the neck vanishes altogether. Then the meander is removed from the river's current and the horseshoe-shaped oxbow lake is formed. Playas are formed from multiple things that leave a depression, soil erosion, wind, and animal herds. Playas are small, shallow, and circular lakes that are ephemeral and only form at certain times of the year. Playas are common in dry plain areas. They are important habitats for migratory birds. Man-made lakes are pretty self-explanatory, but they're usually water reservoirs formed from damming rivers, old quarries, or mines. Now that we've talked about the 3 different types of lakes, let's get into different zones. Lentic habitats are characterized by the shoreline, sides of a basin, the surface of the water, or the bottom sediments. Lentic habitats have 3 zones: the littoral, limnetic, and profundal zone. The littoral zone is along the shore where light can penetrate to the bottom. This is where rooted plants can grow. The shores have coarse sediments from action of waves. Animal life includes invertebrates common to lotic habitats and small fish. The limnetic zone is the upper open water area of a pond or lake. There is a lack of rooted plants because light can't penetrate to the bottom. Animal life includes plankton and fish. The profundal zone is the deep bottom water area. There is no light penetration, therefore no photosynthetic organisms or rooted plants. Sediments are silt and clay mixed with organic matter that settles to the bottom. Organisms living there are tolerant of little or no light or oxygen. The difference between a pond and a lake is a pond is a body of water where light penetrates all the way to the bottom, whereas a lake, the depth of light penetration varies from several inches to feet. In ponds, the temperature stays above the same from top to bottom. For lakes though, during the winter the temperature can remain the same from top to bottom layers, but in summer the surface can be warmed up by the sun while the colder water stays at the bottom. Lakes and ponds evolve differently than flowing water ecosystems. Over time, sediments become higher on the floor of ponds and lakes and build up. The shallower the lake becomes, the further light can penetrate, so more plants grow on the bottom. The lake gradually fills with organic and inorganic sediments, shrinking the area of the pond, eventually filling up the lake. There are 5 types of ponds: cypress ponds, bog ponds, meadow stream ponds, mountain ponds, and farm ponds. Cypress ponds are commonly found in the central or lower Mississippi basin with mostly brownish water. Many of them dry out during different parts of the year. Bog ponds are found in the moist temperature region of North America. The water is highly acidic and muddy. Floating leaf plants cover the surface. Meadow stream ponds are areas where a stream widens and the speed of its current slows down tremendously. The shallow part of the pond usually has an abundance of pondweeds, cattails, stoneworts, and other plants. Floating leafy plants on the surface of the water such as lilies and water shields. Mountain ponds are formed by glaciers. They usually dry up during the summer. The bottoms range from being rocky, graveled, or muddy. Farm ponds are man-made ponds built to keep the farmlands fertile. Farm ponds usually become abundant in fish and are usually good waters for swimming and boating. The next field trip I will be talking about is the Mitchell Lake and Wastewater Treatment Plant field trip. So I didn't have the opportunity to go to Mitchell Lake or the wastewater treatment plant, but I did have a few classmates that did go, and who did give me information on the trip. So Mitchell Lake is located on the southern side of San Antonio. Mitchell Lake is one of the last critical stopover grounds for birds before the Texas coast, where 98% of long-distance migratory bird species in the U.S. pass through, many of which are about to fly for hours or days over our open ocean, making Mitchell Lake one of the best spots for birding in San Antonio. So SAWS also has a wastewater treatment plant located on Mitchell Lake. It is the biggest treatment plant in San Antonio, with 100 million gallons of water cleaned each day. So the water that comes from our toilets and sinks and showers goes to Mitchell Lake to be cleaned. The water cleaning process can take hours or even days depending on the toxicity of the water. So once they clean the water, they dump it out immediately into the Medina Lake to go through the water cycle. If the water doesn't go through the water cycle, then it is undrinkable. That is why they put it in the Medina Lake. On to our next topic, we have the SAWS project. The SAWS project was one of the projects we had the chance to work on. What it basically was that each person in our class got a topic from a random topic picking machine of doom or something, and each person would have to make a slideshow or video of the topic. All the topics were related to SAWS in a way. For example, I had brackish desalination. So I did my project over the new brackish desalination plant located in San Antonio. So now that I've gotten you on the topic of brackish desal, let me briefly summarize my project. So, I did brackish desal. Brackish desal is the process of removing salt from slightly salty water. San Antonio, believe it or not, has their own desal plant located on the south side of San Antonio. Usually when someone says desalination, you immediately think of ocean water. Well, this is brackish desalination. Brackish water is water that is less salty than ocean water, but more than fresh water, meaning we don't have to pump it from an ocean hundreds of miles away. Better yet, we have a brackish water reservoir 1,600 feet below the ground. So that water gets pumped up into the H2O center, and they desalinate the water using reverse osmosis, and then they pump the clean water into the Edwards Aquifer for our use. The desal plant creates 9 gallons of clean water for every 10 gallons of brackish water, creating 12 million gallons a day. Our next ecosystem is wetlands, swamps, and marshes. Wetlands are very beneficial to the environment. These are called ecosystem services, benefits that ecosystems provide to people. These services can be classified into 4 categories: provisioning, regulating, cultural, and supporting. Provisioning can be described as goods or products obtained from ecosystems, such as food, timber, fiber, and fresh water. Regulating are benefits obtained from the ecosystem's control of natural processes, such as climate regulation, disease control, erosion prevention, water flow regulation, and protection from natural hazards. Next is cultural, which are non-material benefits such as recreation, spiritual values, and aesthetic enjoyment. Lastly is supporting. These services are the natural processes, such as nutrient cycling and primary production, which maintain the other services. Wetlands provide many ecosystem services. Here's a picture of how some of them work. Some ecosystem services provided by wetlands are the extensive food webs and rich biodiversity they support. Wetlands are called the kidneys of the landscape because of the filtration functions. Wetlands also provide some medical products to the people. An extract from the horseshoe crab's blood is used to test the purity of medicines. Wetlands are considered the birth of modern civilization because they gave rise to farming, which were critical to the development of the survival of early human civilization. So, what is a wetland? Well, a wetland is an area where water covers the soil all year or for varying periods of the time. The few types of wetlands are bogs, swamps, and marshes. A bog is a type of wetland that accumulates a deposit of dead plant material. Its moisture is provided entirely by precipitation and has a highly acidic pH of less than 5. Swamps are dominated by woody plants such as shrubs and trees. Swamps are often near rivers and streams, and as the river or stream floods, it carries nutrients to the swamps. Marshes are different because they have grasses, reeds, and sedges without shrubs and trees. Marshes can be saltwater or freshwater, and are usually areas of large open waters. Marshes protect neighboring areas of land from flooding. Our next field trip is Confluence. Confluence was a very interesting trip. For half the time we didn't really know what we were doing or what was going on, but I'll start you off with what we did. So we got to the Woody and we went into this room, and you walk in and there's so many different schools and programs about saving and preserving water. The best way I could describe it is if you've ever been to a science fair. That's pretty much what it was, except there's no competition and it's all about conserving water. So we walk in and me, Gabe, Camden, and Alex are just walking around gathering information for our field trip assignment. And we pretty much just walked in a circle for like an hour and a half, just gathering information and passing time. One thing we did was Gabe and I participated in like a water trivia. They pretty much just asked us a bunch of questions about water. Did you know it takes 85 gallons of water to grow an avocado? Anyways, I feel like Confluence is a really good program because not only does it let teenagers get involved with making a difference, but it gives them an opportunity to invent more efficient ways in conserving water. One of the field trips our class had the opportunity to go on was going to SeaWorld of San Antonio. I feel like this was probably a lot of people's favorite trip just because of the fact that we got to see up close some of the animals they take care of behind the scenes at the actual amusement park. Although watching the amazing animals perform wasn't really the purpose of our trip, it really did make the trip that much better. Our main purpose for going to SeaWorld was to see the way they conserve water, and although they use millions of gallons a week, they are still reusing and conserving every drop. So in the next few minutes I will be going over some information that I got to collect while at SeaWorld. So let's start with their daily routine. So, they take 3 different samples a day to ensure that the tanks specifically for the dolphin tank are right for the animals. The 3 samples they take daily are pH, salinity, and the chlorine level. And they test the chlorine level 3 times a day to make sure it's not too high for the animals. So with a daily water test, every 2 months they sample all the pools and send them to Orlando for a full sample analysis for results. And so then they can make major adjustments. They take samples of minerals like metals, salt, sodium, potassium, and other minerals. So on to the next is the recycling. SeaWorld has really made a big effort to save as much water as possible so that it doesn't go to waste. So it's obvious that when they are training the dolphins, they definitely splash a lot, and a lot of that water goes outside the pool. Well, SeaWorld collects all that water that falls out of the tank and cleans and filters and reuses it. Maybe they don't put it back into the pool, but they definitely reuse for something, and that's what counts. Now we all know this famous Shamu splash zone and how he does the tail whip and the splashes the crowd. Now I'm not sure if they collect the water that Shamu splashes at the crowd, but I'm sure they do because just that is a lot of water going to waste. During the winter when it gets cold, they have a room with a boiler that warms the water for the dolphins, and in fact they have security guarding the water quality treatment plant, which is also where the dolphin and several other animals are. But not only do they have security on guard 24/7, they also have like workers there at all night to make sure everything is working smoothly, and in case of an accident, they're there to fix it. So to work in the water quality treatment plant, you must have taken chemistry and biology in college, which I thought was really interesting because it shows that they don't hire random people. They care for their fish, and they only want experienced people. Last but not least, we have aquariums. Aquariums is probably one of the more interesting topics just because of the amount of fun we had doing it. So I'm going to take you through the year on what we did with aquariums. So for the majority of the second quarter we had only 1 fish, and every day we had to take a few measurements/tests. We had to check the pH, the temperature, and the nitrate and ammonia level of the fish tank. We took those measurements for about 3 weeks straight. After that we actually had an assignment on which we had to make a website for our aquarium. So each person had to bring a fish, so at this point we had about 6 or 7 fish maybe. So yeah, we made a website about our fish and each person did research on their fish, and we each had a subpage for our fish. So after that assignment, our tank kind of went downhill. I'm going to be honest, we didn't take care of our tank at all after that. That explains why we had like 4 of our fish die. Speaking of which, I have access to never before seen footage of one of our fish's funeral. Take a look. So every once in a while we would deep clean our tank, as in we would take out all the fish and empty the water and whatnot. This was kind of hectic because we had like 6 people in our group and like half of them wouldn't do anything, so they would just stand in the way. But besides that, taking care of the aquariums is really fun. Just look at this video.
Oh, there we go, we got it. I'm gonna like put this up and like it's gonna go over us. No. Okay. On fluid. That's enough.
In regards to this tank,
Turn it off! It's clean!
What are you doing?